Hi guys, welcome back to another video of Next Gen Coders. Today we'll be discussing what an algorithm is, how we can use it, and how we can perform it. Okay, so the definition. An algorithm is basically like a step or by-step process of how to solve a problem. And this can either be in respect to coding, or it can just be some basic algorithm that we can perform in our daily lives. And algorithms always give us a correct answer no matter what is inputted. And typically the best ones are the ones that always solve it the fastest, the more efficient ones. Now, let's talk about the proper way an algorithm performs. First of all, it gets input from the user. Now, this may be, hey, what's your favorite color, or something really simple. Next, an algorithm, it'll perform its basic steps and procedures in order to get proper output. Now, here's a flowchart. This is basically, I guess, the proper way of demonstrating algorithms. And a flowchart is basically a diagram expressed by shapes or arrows, and it's creating a path for the decision to follow. As you can see here, we can see this image, and it's demonstrating how to satisfy your hunger. Now, it's giving us where we should start, and then it's going to go through all these various decisions in order to come to a final destination on whether to plate up or order pizza, and then we're done. Now, the basic building blocks for algorithms are sequencing, selection, and iteration. Now, we're going to be talking about these in case you may be like, what are these? I have no clue. Well, we'll find out. Okay, sequencing. Sequencing is basically like a step-by-step process placed in the order in which they're performed. So this is very crucial to place all of the events in the specific order in which they're performed in order for the algorithm to run properly. Now, we have this short example. Now, this one isn't necessarily in regards to coding. This is more something that we may perform in our daily lives. But still, I think that this should make sense for you guys. So for this, it's basically a simple example of how to make a cup of tea. Now, the first step is to boil water. Second one is to pour water in a cup. The third one is to place the tea bag in the water. Fourth one is to add some sugar and milk. 5 is to stir until contents dissolve. And the sixth step is to enjoy. Now, if you notice that these steps are placed in numbers ordered in which the way they occur. For example, if we put 5 in place of 1, stirring contents until they dissolve, and then 1 right here, we can see that it's not really going to make much sense. So that way, it's crucial for all these steps to occur in the order in which they're put. Our next building block for an algorithm is called selection. And we'll be talking about why I said this in a few minutes. But selection is basically an algorithm that may execute in a different set of steps based on Boolean values. And if you don't know, or if you're not really familiar on a Boolean value is basically a true or false statement or an if or else. Now, we can see this in basic kind of coding, like, for example, Scratch or Python. It's basically some kind of condition will happen if something else is true or false. So, for example, if there are no people on the road, then the car can cross. If there are people on the road, the car has to wait. So that's using an if or else statement. If being car can cross if there's no people, else being that if there are people, car has to stay in its place. Now, as you can see here, I've taken the same example of how to make a cup of tea, but I've incorporated a selection statement. Now let's just run through this and I'll explain the selection statement that has been included. So, how to make a cup of tea. First step is to boil water. Second, pour water in a cup. Third, put tea bag in water. Fourth, add some sugar and milk. Now, here is where the selection statement has occurred. And we can identify this from the if or else mentioned right here, the A and B. So, let's say some of you might be a little bit of a sweet tooth, like you may really like some sugar, okay? So, if sugar is needed, add sugar. But then other people, you guys may not like sugar. You might not be a fan. You might like that bitter taste. Then, if sugar is not needed, skip sugar. So this is basically running through asking, hey, do you want sugar or do you not want sugar? If you want sugar, add the sugar. If you don't add the sugar. But even after the step is performed, notice how it still goes to the next step, step 5. So even if I want sugar or if I don't want sugar, at the end, we still go to step 5, stirring until the contents are dissolved. That is selection. Now let's go to iteration right here. And again, you might be seeing that must indent. Well, we're going to talk about that after. Iteration is basically the repetition that an algorithm uses to execute the steps a certain number of times or until a certain condition is met. Now, this can be used for the efficiency of a program because let's say that if I want to, run through a certain number of steps, okay? Certain steps multiple times. Would it be easier to just put all the steps together? Like, let's say I wanted to run it like 10 times, okay? So would I put the step, copy and paste it 10 times? Or would it be easier to put like a loop or something like that says, run this 10 times? That's it. The second option, right? Because that takes up, first of all, like way less code. And second of all, like, okay, so if you want to debug it, like go through it, you find an error, do you really want to look through each of those 10 chunks of code? Or do you want to just look at that one chunk of code that says repeat it 10 times? Right? Okay. Hopefully that makes sense. So we can use while loops. While loops are basically this type of code that runs through until a certain condition is met. Like, for example, while blank is greater than blank or something like that. So it'll keep running until this condition is true. Otherwise, we could also use for I in range loops. I is basically like an unknown integer which we can replace for any value. So for example, if we're going back to the case where I'm saying I want to repeat it 10 times, we can replace I with 10. So we can say for I in range, and then we could set I to 10, okay? But don't really focus on that. We haven't really covered all the Python or the Scratch or any of that coding. We're just going to be focusing on the basics for now. But I promise you this is going to make sense much later. So once again, we're going back to this example of how to make a cup of tea, except we've added iteration to this. So first we boil water, second pour water in the cup, put a tea bag in the water, add some sugar, and as you can notice here, we still have the selection statement, the if or else. Oh, okay. And right here, step 5, we have a while loop, or while contents are not dissolved. Stir until contents are dissolved. As you can see here, we're using a while loop. So we're saying right here, hey, until these contents are like properly mixed together, like we can't see any of the sugar crystals or all the milk or anything like that, we're going to keep stirring. So until that happens, we're going to keep stirring until we find no more sugar crystals, until like everything's properly mixed together. Once again, after this condition is met, so it's going to keep running, okay? Step 5 keeps running until all the sugar crystals, all the milk is all dissolved. And then, once that happens, then we move on to step 6, which is enjoying. Cool. Now, we have pseudocode. What is that? Okay, well, pseudocode is basically, coders, they like to take the algorithms. Algorithms are basically used, to help make coding an easier way, right? So if I have this complex set of code, then I can simplify it down by making it into an algorithm. Now, if we notice here, this stuff isn't code, okay? Code is, I guess, more complex, okay? This one is something that we can read ourselves and we can understand. But we can't put that in the code and expect that to run, right? Well, pseudocode is basically taking our algorithm, something that we can read, and then turning it into the program format. But when we turn it into the program format, it's not running anywhere. So we're just like changing it up and making it like more suitable for coding. But yeah, we're not running it anywhere. Now we're gonna take a look at the next slide for as an example, and this is in Python. So if you don't understand completely, then that's okay. We're going to be talking about a basic tutorial on Python a little bit from now, but just hold on until then. I'm gonna try and explain it in the best way possible, but okay. So as we can see here, just like a brief overview, the hashtags are the comments that are used throughout the code. So all these stuff in white, they don't really mean anything. Hashtags are meant for us. So this one doesn't affect the code or anything. They're just meant for us to basically more understand it better and I guess simplify the process. So like if we want to debug it, we don't have to go through all this code and be like, oh my god, what does this do? Well, we can see right here. Hey, this part asks the user for their C preferences. So yeah. Okay, so as you can notice here, the difference between this one and then this one, they're like extremely different, but not really. Because this one right here is more in the coding format, right? Like this, you can put this straight in Python, which is a coding language, sorry. But and this would work. This one, if we put in Python, it's not gonna work at all because it's not in proper format, I guess. So sugar needed equals input. This is basically just a variable. And this part is basically just asking the user, okay? So the user is basically us, okay? The computer is going to ask us, do you want sugar? Okay? Either we could say yes or no. So let's say if I say yes, okay? Now we're going to go to the next step. Now the computer is just going to be telling us, hey, we're boiling some water. Then the next one, it's going to be telling us, now we're pouring hot water for your tea. The next one is saying, now we're going to be putting the tea bag into the cup. Now here is the part where oh my god, why do I keep doing that? Here's the part where our input really matters because it's saying if sugar needed equals yes. Okay. We can see here that sugar needed is the same as this one. So what they're doing is checking that if our answer for this question is yes, which it was, then what we're going to do is be adding the sugar. We're going to add the sugar into your coffee or tea, sorry. Okay, but let's say if it was no, okay? There's nothing that says if sugar needed equals no, right? Basically, you can add that if you want. Hypothetically, you can add that, like saying else if sugar needed equals no, then you can say I'm not going to add the sugar. But for the purpose of this one, it's just saying that if you need sugar, then add the sugar. Otherwise, move on to the next step. Okay, so let's say we're going to stick with our example, okay? I added the sugar and everything, so it's much sweeter. Next, we're going to move on to the next step, which is saying print stirring the tea. So now the computer is going to be telling us, hey, we're stirring the tea right now. Then we move on to the next step, where it's saying, hey, your tea's ready, enjoy. Okay, so this is basically the set of steps. And notice how everything, it plays a role. So if we move this, if we move stirring the tea up here, that doesn't make any sense, right? So the order in which all of these steps occur is like really crucial. It's so important for us in order for the algorithm to function properly. And okay, now moving back right here. Now you might still be wondering, why does selection and iteration say must indent? Well, for example, if we look at the selection statement, the if sugar needed, we can see that there's a colon here, right? And then we have this huge indentation. Well, that's because we're not going to go through it really deeply today, but basically, if you see selection and iteration statement, whatever happens inside of it must be indented for the program to function properly. Yeah, that's all you need to know for now, at least. Once you learn Python, once you learn all of the basics on that, you'll understand it more. But for now, just, I guess, focus on all these things. If you understood everything from there, then you're pretty good. But yeah. As always, let us